Today we're doing section 2.1, complex numbers, and this is the second day of this lesson. So today we're going to talk about division with complex numbers. So in Algebra 2 last year we did talk about multiplying, subtracting, and adding, and that was what we did in yesterday's video. Now we're going to discuss division, and this is something that would be brand new that we did not learn last year. So we're going to have to use something called the conjugate, and the conjugate just says if I have a positive a plus bi, that means I know that I'll have an a minus bi, or vice versa. So if I have the minus, I would be inputting a plus. So notice a, the sign of a stays the same. It's the sign in front of your imaginary unit is what is changing. So for our first example, I have 4 divided by 2 plus I. So division of complex numbers really is not division at all. It's actually going to be multiplication, and we multiply by the conjugate. So we're only worried about the denominator for these. So I need to identify the conjugate of the denominator. So the conjugate will become 2 minus I. And we know whatever we do to the bottom of the fraction, I have to do to the top of the fraction. So in the top of the fraction, I would distribute, and I'll have 4 times 2, which is 8, minus 4i. In the bottom, we have to FOIL. If you box, this is where you would box. So 2 times 2 is 4, and then I'll have minus 2i, and I'll have plus 2i, and then I'll have minus I squared. So in the denominator, these two cancel out, and if you recall from last year and last video from yesterday, that I squared is equal to -1. So in the denominator, I would say this will become minus a -1. So that'll change into being 4 plus 1. Oops, I'm ahead of myself. So it'll be 4 plus 1, which will give us 5. So I have 8 minus 4i all over 5. So notice by multiplying by the conjugate, it gets that I out of the denominator. So just like we're not allowed to leave square roots in the denominator, we're not allowed to leave i's in the denominator. So let's try another one. So here we have 7 plus 4i over 2 minus 5i. So again, you're only worried about the bottom, and so the conjugate of the denominator will change to be 2 plus 5i. And whenever I do the bottom, I have to do to the top. So this one I'm going to have to FOIL in the top and the bottom. So if you do the box, you'll make 2 different boxes. If you FOIL, go ahead and start FOILing. In the top, I'll get 14 plus 35i plus 8i plus 20i squared. In the bottom, we'll get 4 minus 10i plus 10i minus 25i squared. And notice in the bottom, these two terms will cancel. You always should have something like that happening. And I squared is equal to -1. So this will change to being minus 20 in the numerator. So 14 minus 20 will leave me with a -6. And my imaginary unit will have 43i in the numerator. In the denominator, this will change to being plus 25. Plus that 4 will equal 29. So again, notice I removed the imaginary unit from the denominator. So that's how we divide complex numbers. I'm going to go over one more topic, and that's simplifying with a negative underneath the square root. So something that we learned last year, if I have a negative b, let's say underneath the square root, we fix it by taking out the imaginary unit, and I change it to being a positive b. So the imaginary unit will represent a negative underneath a square root. So we're going to do a few examples just practicing that skill. So here we need to simplify both of these square roots first. So an 18 can break down to be the square root of a negative 9 and the square root of 2. And the square root of negative 9 will give me 3i root 2 minus the square root of negative 8 can break down to be the square root of negative 4 and root 2. So the square root of negative 4 is 2i, and that root 2 stays. And because these both have a root 2, they're considered like terms, so I can combine the outsides. So 3i minus 2i will leave me with 1i root 2. If those 2's underneath the square root were different, if one was a 2 and one was a 3, then you would be done there. It would not be able to go any further. So that's the final answer for that one. And remember, if you're confused as to why I picked the 9 and the 4, you have to pick your perfect squares, which are 1, 4, 9, 16, 25, and so on. Let's try another one. So here they want us to square this quantity. Before I square the quantity, I need to fix the fact that there's a negative. So when I write it twice, I'm just going to fix this up by saying I root 5. You do have to address the negative in the first step by replacing it with the I. If you don't, you will get a different answer, so it's very important that you do that step. And now we FOIL, or if you box, you can box here. So my first term will be positive 1. Then I'll get a negative I root 5. I'll get a second I root 5. And then I'll get plus an I squared square root 25 for the last term. And I know I squared is equal to negative 1. And I know the square root of 25 is equal to 5. So this is actually going to turn into just being minus 5. So I can combine the 1 and minus 5 and get a negative 4. And again, because these both have that like term of root 5, I can combine the outsides. So I'll say minus 2i root 5. So that's our final answer for that one. So we're going to just do one more. So notice this looks very something to the result of what you would get by using quadratic formula. So quadratic formula is going to come back in the near future in the next few sections. So we're just going to practice simplifying with negatives to make sure we still can do that. So I'm going to pull this off to the side. And we know 25 can go into 50 2 times, and the square root of negative 25 would be 5i root 2. So I'm going to take that and put that back into the problem. So I have negative 25 plus 5i root 2 all over 15. And because all three of these outside numbers, the 25, 5, and 15, are all divisible by 5, I expect you to do that. So this will become negative 5 plus I root 2 all over 3. And this is our final answer. So notice you do not worry about the value underneath the square root. So this is all for today. We'll pick up with this lesson tomorrow.